Design of storm water drainage system in a metropolitan area. Abstract: a scientific drainage system to catch the storm water is a long-term need of the society, particularly in cities. Urbanization along with its impermeable structures is one of the major causes of flooding in metropolitan areas. The rainfall intensity and characteristics of catchment area are the major factors for designing metropolitan storm water drainage facilities. These facilities have a uppermost advantage to safely dispose the generated floods to receiving system. Many towns lack in providing proper drainage system. The present design helps the rainfall and design storm water drainage system. Past record of 34 years rainfall data has been taken for study. Various methods were reported in literature for runoff estimation. In the present study, rational method has been used for estimation of storm water runoff, which is widely reported in literature. The present study is to estimate runoff of a drainage basin and also to design as a case study for Navrangpura area in Ahmedabad, Gujarat, where the design is based on different velocities. Keywords: drainage, rational method, runoff, storm water. Introduction. Storm water drainage is the process of draining excess water from streets, sidewalks, roofs, buildings and other areas. A system which used to drain storm water at various places. It has different names like sewers and drainage wells. Storm water can be any rainfall, such as rain, snow and sleet that falls on the surface of the earth. Structural measures to control storm water include storage reservoirs, flood embankments, drainage channels, anti-erosion works, channel improvement works, pipe cleaning work. Detention basins and non-structural measures include flood forecasting, floodplain zoning, flood proofing, disaster preparedness, etc. In areas with natural groundwater, about 10% of the precipitation becomes runoff and about 50% infiltrates into the soil to form or replenish groundwater and flows into streams. Evaporation and uptake by plants accounts to the remaining 40%. When natural conditions change due to development, land use, and other activities, this water cycle becomes altered. As the land becomes more covered with impervious surfaces, more rainfall converts as runoff. This runoff carries the dust, other loads, and pollutants. When the development is more, as much as 55% may become runoff. Storm sewers, also storm drains, are large pipes or open channels that transport storm water runoff from streets to natural bodies of water, to avoid street flooding. Storm drains vary in design from small residential dry wells to wide municipal systems. Various storm drainage systems are designed to drain the storm water, untreated, into rivers or streams. A combined sewer is a type of sewer system that collects sanitary sewage and storm water runoff in a same system. Combined sewers can cause serious water pollution problems due to combined sewer overflows, which are caused by big variations in flow between dry and wet weather. Figure 1, Storm Water Catch Basin. Any storm drain in the area may be discharging various quantity of water and also the type of pollutants it contributes. Since the metropolitan cities becoming densely populated, the per household volumes of wastewater exceed the infiltration capacity of local soils and hence require greater drainage capacity and the introduction of sewer systems. Navrangpura is an area in Ahmedabad, Gujarat. Population is increasing day by day due to its increased population, and commercial activities are also increasing. The drainage system in Navrangpura is through pipelines. All domestic wastewater generated in the basin is discharged through pipes and flow at river. These pipes have various problems like improper slope, erosion, leakage, and self-cleaning velocities. The leakage flow creates stagnation of the sewage, creates odor nuisance, and creates mosquito and files problems, and also causing deterioration to river water quality. Various methods are available at the moment for reduce this problem, and one such method is storm water drain design. In hydrological analysis, various studies are carried out on storm drainage design. One of the study by Mr. Altaf Hussain, 2016, rectangular cross-sections of drains for 3 catchments were designed using Manning's equation according to peak discharge. P. Sundarakumar, 2015, make model which utilizes the rainfall and design storm water drainage system. T. Siva Subramanian, 2014, found that remote sensing and GIS is a useful tool for spatial planning of stormwater issues. INTCAVOS, 2016, determined parameters that are important to consider in deriving a DEM error budget. Specifically, terrain slope, land cover type, information loss, and data measurement schemes. Harshal H. Gadger, 2014, designed diameter of pipes as well as discharge of pipe at Jodhpur Ahmedabad Need Hidasan.s and Manoj Nalanathal, 2013, stormwater drainage design at Kerala. Keshav Basnett and Keshav Barnett, 2017, analysis area of Pokhara, Nepal and design side road drain system as well as upgrade the existing drainage system. Priyanka D. Harpalani, 2013, develop rainfall intensity vs duration and design of drain is carried with help of Manning's chart and study area. Ankit Balvanchi and H. L. Tiwari, 2014, the Natural Resource Conservation Service curve number technique is very helpful tool for estimation of direct runoff from storm rainfall. Bangar Sunil R. Patel Pramod Z. and Kashid Vinod, 2018, the details methodology to prepare plan for watershed development of a village. 2 objectives. 1. To understand existing drainage system and relevant problems of Navrangpura. 2. To understand the rainfall pattern and respective runoff generation by analyzing previous year's data. 3. To analyze and design the drainage system of Navrangpura, Ahmedabad. 3. Study area. The geographic location of the Navrangpura area is located in Ahmedabad district of Gujarat state and lies between latitude 23.036706 n and longitude 72.561066 e. The geographical area of Navrangpura is 11.98 square kilometer. The months of April to June are the summer months with the temperature ranging from a minimum of 27.0 C to 44.0 C. The temperature during winter months ranges from 270 C to 160 C. The annual rainfall in the region is about 772 mm and is contributed by the southwest monsoon. The average number of rainy days is 34 in Ahmedabad. Excessive falls of rain during June to August cause frequent floods in the rivers and canals submerging low-lying areas. Navrangpura area is located on banks of Sabramti River. This area is at the center of Ahmedabad. Navrangpura is considered as the educational and commercial capital of Gujarat. Very famous colleges in each and every field are in this area like M.G. Science, LD College of Engineering and Technology, GLS Law College, CEPT University etc. Very well-known saloons, shopping malls, hotels, restaurants, hospitals, and cafes are in this area. Big projects like Metro is going on in this area. Gujarat government gives higher focus on this central area. In the field of infrastructure development, this area also contribute more in Ahmedabad city. The key plan of the study area is shown in the figure 1. The main reason for the problem to be so acute is the poor drainage network in the area. Absence of drainage network also results in the indiscriminate discharge of wastewater into the water bodies. The storm water during the heavy rainfall in the area leads to block the roadways, canals, and other sub-roads, which leads to interruption of traffic, transport, trade, education and other works. 4. Methodology. The field data required for the design of the sewerage system, such as details of exiting water supply, the ward-wise population as per census, development plan etc. were collected from the Navrangpura Municipal Council. In the present study, rational method is used to estimate discharge for the Navrangpura. Discharge is a major input for the storm water design, and also the geographical information of the city is essential to find out the general slope of the ground, which helps in finalizing the alignments and directions of the sewers. Soil data was collected from the ICAR National Bureau of Soil Survey and Land Use Planning Regional Center, Udaipur. Google Earth Pro is used in many fields like making movies with Google Earth, using layers, using places, managing search results, measuring distances and areas, drawing paths and polygons, using image overlays, using GPS devices with Google Earth, tilting and viewing hilly terrain and many more. Area of Navranpura with Google Earth Pro. Take different pinpoints through Pin tool and with various longitude and latitude mark points. After that choose Polygon tool and join all points and get whole study area. After completion of joining point we have various options like style, color, view, measurement etc. Figure 3, Area Measurement in Google Earth Pro. B. Elevation Profile. In this Google Earth Pro is used for measurement of elevation as well as elevation different of Navrangpura area. Whole area was divided into 3 zones and taken 7 node points. With the help of line tool create a line which joins 7 node points, and through show elevation profile option I got elevation of whole area which shown in below fig. The existing pipes of city from zone 1 to zone 3 carries maximum water, and in rainy season the storm pipes and roadways both carries the high runoff. This occurs because the inlet is insufficient to carry the initial discharge, which truly affects the capacity of the pipe from zone 1 to zone 3. Table 2 shows various details like weighted area, time of concentration, segment runoff flow from different points and elevation different. It is useful to find runoff from the zone to zone. Table 3 shows the detailed design features of the drainage system. It shows the possible discharge generation at different velocities. As mentioned in FAEO manual and storm design manual, the velocity may vary from 0.3 to 3 m/s. Therefore at different points different velocities may be generated, so discharge depending upon that. V. Results and discussions. Figure 5, Zone Division of Navrangpura Area. Zone division has been done with considering geographical condition of this area and elevation different, which already show in Table 1. Existing drainage network of Navrangpura area has been surveyed, calibrated, and corrected with the data provided by municipality. Drainage pipes were surveyed to obtain the growth truth and real data of Navrangpura area. The measured depth details cross-section and all the length were compared with existing maps of storm network. In manual design various aspects were related and considered. All the required information like area of Navrangpura, elevation profile, and slope was found from the Google Earth Pro and analyzed with the help of various formula. 6. Conclusion. Navrangpura area is facing strong water drainage problem due to increasing population and infrastructural activities. The inundation of the study area is mainly due to the blockage of the drains in different points, therefore periodical maintenance of existing drains is essential. Google Earth is software in which we can easily find area perimeter and elevation different. Rational method has been successfully used for the estimation of storm-wise discharge in Navrangpura area. This study can be helpful to design storm drainage pipe at other places. 7. Acknowledgement. The authors 8 thankful to the State Water Data Center, SWDC, Gandhinagar for providing the rainfall data. The authors